Okay, so in this video we are looking at prisms, okay? So prisms are basically a 3D shape that has a uniform cross section. Now what this means is that basically whatever is your surface that's at the front or at the bottom, sometimes if it's turned up on itself, then that's the very same shape that is throughout the 3D shape. So for example, our cuboids that we've already looked at in the video on cuboids, that is a type of prism because you have this square shape in this particular type of cuboid. We've got the square shape here at the front, and that square shape is throughout that whole solid shape. In other words, if we were to cut that shape anywhere along, the minute you'd open it up, the new front of the shape would be a square as well. So we have triangular prisms, cylinders are also prisms, and even if you have some sort of irregular shape that's at the front surface, but no matter where you would slice down that 3D shape, you would still end up with the very same shape at the front as you had at the original front, if you like, then that is also a prism. And what you do to get the volume of these prisms, it is just the area of that cross section, in other words here, that front surface, so whatever that is, times by the length, or I like to sometimes call it the depth. Okay, so it goes to make sense then with the cuboid, which we know the volume of a cuboid is length times width times height. Length times width, of course, is the area of the front shape. And then height or length, you see if it was turned up on itself, it would be a height. But as it here, it's the depth. Then you have length times width, the front surface times the depth or the height, okay? Same then with a triangular prism, the area of the front shape, the front surface or the cross section is a half base times height. We know that already from our area of a triangle, half base times height. And then of course we would times by whatever length or depth this is here, okay? And that's how we get the volume of a triangular prism. Same from a cylinder, area of the circle times by the depth or the height, whatever way you want to call that length there. But how far along that circle is repeated in order to create that 3D shape. Now, I want to talk about what formula are in your log tables. We've already spoken before that cuboids, the formula for cuboid is not in your log tables. Length times width times height, you need to learn off. Now, with regard prisms, the way it appears in your log tables, if you go to the section on surface area and volume, okay, which is here, you see there you've got a cylinder, you've got a cone, you've got a sphere. This is page 10, but if you turn to page 11, then what you're given for prisms is actually here. Now it looks a bit complicated, so I just want to explain it so it is going to be able to help you in the exam remember how to get the volume of any prism. They have an irregular prism here, okay, but they're calling this base B. You see, taking B as the area of the base. So the area of that flat surface at the base is B. And all you multiply then by is the H, which is of course the height. If that was lying down on its side, you could call it the length, as we had it here, length, or depth is another word, as I said, I like to use for it. So don't worry too much about what way we describe that. It is however long that surface, if you like, is being repeated on top of itself in order to create a 3D solid. So it's the area, in this case, times the height, or as I said, if you want to call it depth, that is always how you will get the volume of a prism. Okay? Right, let's try some questions. Okay, so consider this triangular prism here, and we are looking for the volume of this shape. So the formula we're going to use is, well, we need, of course, the area of the front shape, okay, which is area of a triangle, half times base times height. And then you're going to want to multiply by, and as I said, I like to call it the depth, okay? You're always the front surface times the depth. So multiply by the depth. That's how we're going to get the full volume of this triangular prism. So let's fill it in. So we're looking for the V, so we can't fill anything in for the V. A half will stay as a half always, times the base. Now we're just looking at the front shape here, the triangle. So the base of the triangle is 10. The height of the triangle is 6. And the depth of the shape is, of course, 15. All right, so that's what we're looking to do on the calculator. A half times 10 times 6 times 15. And that works out to be 450. Don't forget your units. Centimeters cubed, of course, because it is a 3D shape. All right, now let's try this type of prism. Now, this is kind of a different kind of prism that we're used to. We've got a pentagon shape at the front, all right, which we don't know how to get the area of. We don't have a particular formula for that in our log tables. But luckily, we have, of course, the area of the front surface, okay? So the volume of any prism, and in particular an irregular prism, is the area of the front surface times by the depth. Again, I like to call it depth. If you want to call it length, or of course if it was sitting on top of itself, it would be possibly considered height, okay? But that's basically what we're looking at. We're looking at this shape here, this surface flat shape, and that's that surface flat shape that's repeated all along this length of 52 centimeters. So V equals the area of the front surface. I don't need to do any working out on that. I have it already, which is 280, and then times by the depth, which of course in this case is 54, and the answer works out to be 15,120, and of course it is a 3D shape, so centimeters cubed. So let's look at a question where we have a triangular prism, but we are missing a length, okay? So we're being asked to find this length here called x, but we're given the volume, which is 540 centimeters cubed, okay? So your volume of the prism, of course, is the area of the front surface, if you want to remember it like this, times the depth, okay? Remember how it is, of course, in your log tables. The only hint you have is to remember it's the area of the base times the height, or the way we have it drawn is the area of the front times the depth. So I have that written out for myself, and now I'll fill it in. The area of the front surface, of course, is a half times base times height, and then we'll times by the depth. Okay, so now I have that written out for myself. I've identified the shape and I've identified what we're talking about, which is volume. I've got the formula written out in full. Let's fill in what I know. So you know what we have for the V? 540 can be subbed in for the V. Then we have a half, that'll always stay a half, times the base. In this case I have written down as x, so I'll write that in as x, times the height, which is 6, times the depth, which is 15. Okay, so now what I'm going to do next, I have 540 here on the left hand side, and the bit of working out I can do on the right hand side is the half times the 6 times the 15. Okay, so that's what I'm going to work out. I'm going to work out a half times 6 times 15. Okay, and that gives me 45. So I have 45 times the x. And of course, your whole idea is to want to get the x on its own to figure out what that length is. So how are you going to get rid of something that is being multiplied by 45? Well, we divide by 45. If you divide by 45, that gets rid of that and leaves you with the x then on its own. And of course, if you divide the right hand side by 45, you've got to divide the left hand side by 45. And 540 divided by 45 works out to be 12. And of course, it is centimeters. Okay, so now let's look at surface area of a triangular prism. Okay, so surface area is of course the area of each surface. All right, so this is where our little strategy from our video on cubes and cuboids, when we were doing surface area of cubes and cuboids, my approach was to look at each of the surfaces individually, okay? Now there's a quick way of doing it. You can speed that up when you're dealing with cuboids, but I said what would be very useful, especially when we come to these more complicated shapes, and especially a triangular prism, it is going to be useful to look at it surface by surface, and so doing that layout that I had used for cubes and cuboids. So that's the approach I'm going to take here. I'm going to look at each surface, each 2D surface, and get the area of each of those surfaces, and then add them all up together. Okay, and that of course makes sense when you get a question about surface area, that's what you're doing. You're getting the area of each surface and you're adding them all up together. Okay, so let's have a look at the front of the shape. So the front of the shape, we can see that that very front surface is a triangle. So what's the area of a triangle? Well, it is a half times base times height. Okay, so that's the first thing you're going to want to get clear for yourself, is what is that shape, what is that surface shape, and what is the area of that shape, and get that written down. So filling that in, we have a half times the base, of course, is 8, and the height is, of course, 6. So the answer I'm getting for that is 24 centimeters squared. Okay, so now looking at the back. Now the back of this shape, and just be mindful now to just double check this. Don't just assume that the front and the back are going to be the very same, or that the sides are going to be the same. You have to just be very careful, especially when you're not dealing with a straightforward cuboid. Here though, we can see that yes, you have the very same triangle shape at the back. So the back is indeed going to be 24 centimeters squared as well. Right, now let's have a look at the right hand side. Now the right hand side is this surface here, and that surface here, if laid down flat, is of course a rectangle, and the area of a rectangle is length times width. So be careful and make sure you get that formula written down. So the length is 15, and the width would be that diagonal length there. Think of it if it was just flat on the actual ground, or the table if you like. If it was just fallen down flat, that is the width of that rectangle. So we have 15 times 10, which is 150 centimeters squared. Now, looking carefully at the left hand side, so looking at this side here, so from that direction, we're talking about this rectangle here. It is a rectangle there on that side, but it is most definitely not the very same rectangle as what's on the right hand side. So here's where it does get tricky, and you want to be very careful. So that is a rectangle, so length times width, but the length, although the length is 15, the width is going to be 6. Okay, so 15 times 6 is what I'm going to get here. And 15 times 6 is 90 centimeters squared. Okay, so then we're going to look at the base. So the base, if you look very carefully, the shape at the surface of the base is of course a rectangle, so length times width. And the length we can put down as 8, and the width we'll put down as 15, and of course 8 times 15 is 120 centimeters squared. Something to note here, very important, of course, there is no top on a triangular prism. there are only 5 surfaces. So this again is why it's quite useful to do it bit by bit by bit, looking at the shape very closely every time, double checking exactly what shape you have at that surface. And of course we don't have any top, so we're done once we get to the base, and now we're going to add them up all together, and the answer we get is 408 centimeters squared. Right, let's take a look at another question on surface area here. So again, we have a triangular prism. So we'll go about it in the same way. We'll first of all have a look at that front surface, and that front surface quite clearly is a triangle. So half times base times height. So filling in your information, the base of course is 3 and the height is 4. So we have a half times 3 times 4, which is of course 6 centimeters squared. Looking at the back is of course this very same triangle. Okay, so just always double check that. Yes, we're confident that that is the very same triangle at the back. So we have 6 centimeters at the back as well. Now let's have a look at the right hand side. Okay, now the right hand side is a rectangle. We talked about that in the last example. The problem that I have in this question, right, the minute you realize we've got a rectangle, we want length times width. And I have the length, but I don't seem to have this diagonal length here, which would give me the width of that surface on the right hand side. So I must have enough information to figure this out though. And if you look, that length there of course is the very same as whatever this diagonal is of the triangle. And of course it is a right angled triangle. And of course it's a right angled triangle. And in this right angled triangle, that diagonal length is the hypotenuse. And what we can do, if I take that shape here, what I can do, of course, to figure out the length of a hypotenuse when I have the other two sides is to use Pythagoras Theorem. C squared is equal to A squared plus B squared. Okay, so Pythagoras can come in really, really useful in these area and volume questions. So watch out for it. Anytime you have a right angle triangle and you want to figure out a length, then you can use Pythagoras. So remember with Pythagoras, the C must always be the hypotenuse. In other words, the longest side, the side opposite the 90 degrees, in other words, the diagonal. So we're going to call that part C. That's the C in this right angle triangle. So let's fill it in. So obviously I don't know what my C is. And then filling in the A squared and the B squared, it doesn't matter which way round we put these in. Okay, because we're squaring and adding them together, if I do 4 squared plus 3 squared, it will still give me the same answer. So when I do that, I end up with 9 plus 16, which of course is 25. And how to go from squared to just on its own, C squared to C, or to undo the square, we of course square root. So C is equal to square root 25, which is 5. So 5 centimeters is that diagonal. So that's 5, which means that's 5 centimeters. So now, keep that over to the side, I know now that my length of that right hand side is 10, and I know my width is 5. So 10 times 5 is 50 centimeters squared. Okay, so that's my right hand side. Now looking at the left hand side is a rectangle, but with different dimensions. So length times width, the length of that left hand side rectangle is 10, but the width is 4. So that's 40 centimeters squared on the left hand side. Okay, and then that leaves me with the base. And the base again is a rectangle where we have 3 times 10 as our dimensions, okay, and 3 times 10 is 30 centimeters squared. And of course we don't have a top, so we're done. We're going to add these up to get all together, and we get 132 centimeters squared.